Good morning, Camille. Yun. Pinakauna ni si Camille ba? Common use method Hello, good morning everyone. Good morning, Ian. Ready ka na ba sa quiz? Ian? Ian, good morning. Ready ka na ba sa quiz? Ano si Ian, ready na daw. Ready na daw siya. Okay? So, okay, class. So, before tayo mag-start, class, please answer this question para malaman ko kung ready na ba tayong lahat. Alam nyo ba, class, na binibilang ko kung ilan yung mga nag-comment. Okay? So, malalaman ko dito, class. So, class, before that, class, no, before tayo mag-start, please answer this question. What is the most commonly used method for measuring the changes in colligative properties of a solution? What is the most commonly used method for measuring the changes in colligative properties of a solution? Okay, may mga nakasagot, osmometry. May nakasagot na osmometry. Okay? Okay, may nakasagot na osmometry. But the right answer, class, the right answer is your freezing point depression osmometry. Thank you so much for that, Miss Reporter. Okay? So, class, pakisulat naman, class, ating comment section, hashtag freezing point depression osmometry. Don't forget that, class. Don't forget that freezing point depression osmometry. Okay? Pakilagay sa ating comment section, hashtag freezing point depression osmometry. Okay, class. So, sino na naman ang next na mag-report sa atin? Please prepare. Okay, spin na natin yung wheel. Okay? Sige, let's spin the wheel kung sino ang mag-report sa atin. Yun, congratulations! Chromatography. Okay, chromatography. Please prepare. Okay, please prepare chromatography. Okay? Okay, sino yung mga group ng ating chromatography? Hanapin muna natin sila. Okay? Okay. So, pasok na kayo. Pasok na yung mga mag-report. Yan. Please don't forget the freezing point depression osmometry. Siya yung commonly used method for measuring the changes in the colligative property. It is based on the principle that addition of solute molecules lower the temperature at which solution freezes. Yan. Okay, in addition to our sa notes ninyo, class, ha, yung blood plasma ninyo, class, meron tayong osmolality of about 285. Okay, 285 milliosmol. Okay, osmol per kilogram. Okay. So please don't forget, class, that your blood plasma has an osmolality of about 285 milliosmol per kilogram, and it has a freezing point, class, no? Freezing point of about negative 0.35. Yan. Degree Celsius. Okay? So, yung freezing point ng ating plasma, class, no, is negative 0.35 degrees Celsius. Please take note of this. Okay, pakisulat ha, paki-take note kasi wala yan sa presentation. Okay? Sige. Yun. Okay? So, sana yung Gades? Kayo yung mag-report, di ba, Gades?
Yes, sir. Mag-share screen na po, sir.
Ay, sorry. Sorry. Tama si City. Okay, nabaliktad na ako. 50. 0.50. Sorry ha, sorry. Tama, City. Tama. Okay, nalibat. Okay, please correct me ha. Please correct me, class. Correct. Mali ko. 0.53. Okay? Degree Celsius, ha? Yung unit na degree Celsius. Thank you for that, City, ha? Thank you for that sa imuhang correction. Sige, thank you so much. Oo. Maayo na lang na ating mga mata. Sige. Please take note of that. Okay? Anak class ha, naagog ko yung mamali ko or something, please correct me kayo usahay, malibat ba yata. Okay, so, nana ka presentation. I-click lang ang kuan. Diyan eh. Yun. Sige, while waiting sa ating mga class, pili muna ako class na mag-i-entertain sa atin. Sino ba yung mag-i-entertain sa atin ngayong araw na to? Okay, pipili muna ako class ha ng inyong classmates na mag-i-entertain sa atin. Okay? So, let's start with, sino kaya ang lucky winner? Yun. Si Uduya, City Safia, yun. City, pasok ka dito ha. O ikaw gyud ay City. Ikaw gyud ang gipili sa atong kuan. Oh. Ana si City, so kuan Sofyan, patay ka ha. City, pasok ka City. Bago mag-start yung presentation ng mga classmates mo, ikaw muna ang mag-present. Dahan kay ka og kuan dahan kay ka og supporter, iya. Go po ni sige, wait lang daw, sir. Okay, wait lang raw, sir. Okay, so thank you so much. Gades, naka-prepare na ba kayo, Gades? Prepared na ba? Nakapasok ang mga groupmates mo?
Yes, sir.
Sige. Yan, nakapasok na si City. Okay, yan na si City. Okay, sige. Before tayo mag-start ha, mag-intermission muna si City. Intermission, Jude. Okay, asa naman si City? Please turn on your camera, City. Paki-turn yung camera mo. Okay. City, i-turn on yung camera mo, City. Yan. Okay, yan na. Okay, excited na kami, City. Okay, pag-isulat naman dyan sa ating comment section. Excited na kami. Okay, so yun. Pag ready na, pag-isulat sa ating comment section, excited na kami. Okay? City, kamusta ka dyan? Kamusta? City, can you hear me?
Marinig, sir? Ayan niya. Hindi.
Marinig. Marinig ka. Oo. Marami na excited. Marami na excited ng mga classmates.
Ayan na. Marinig, sir?
Marinig. Sige.
May question ako. Ito na, sir. Alam naman siguro ito lahat. So, what do you call a fish made of 2 sodium atom?
Ano daw, classmates? Ano daw?
What do you call a fish made of 2 sodium atoms? Malasan eh.
Tuna.
Sino na una? Si Gretel. Galing. Tama yan kay Gretel.
Fish made of low sodium atom?
Tuna. Isa pa yan. Two.
Ay, binaw, tuda ay, binaw, low.
Yung joke ko.
Low. Tuda ay, tum.
Kayo na yun, sir?
Okay na yun? Wala ka ng
Opo.
additional?
Ay, wait lang. Nerdy mo to sa'yo. What kind of bear? Yeah, madaya! Sir, credits to kay Aya sa kambal ko. What kind of bear dissolves in water?
Ano daw, class? What kind of beer dissolves in water? Okay, may price ba daw yan, Iya? Sabi ni Zara Guman.
Wala, sir. No allowance.
Wala daw, walang allowance dahil lockdown.
Yakit mo yung mga joke ko.
Beer brand daw, may nakasagot na. Tama ba?
Hindi.
Beer brand.
Ang tama kay
Polar
si Goddess Wells Batadlan. Polar bear.
Oo.
Si Goddess ang
Polar
tama.
bear. Okay, thank you so much.
Thank you,
Meron
guys.
power yun na. Okay, thank you so much. Palakpakan naman natin. Palakpakan naman natin yung classmates natin. Sabi ni Francis Ayan, beer brands, no beer. No beer imo. As in, haha, tama.
Gods, walang price, gods. Elvin, kiss.
Sad.
Meron na to kay Elvin na lang daw.
And
Sige. Thank you ha, thank you.
Thank
Sige,
you, sir.
Reporter, pwede na. Pwede na tayo mag-start, reporters.
okay, sir, wait lang.
Sige. It's okay.
Wait. Makita yung sir, PPT.
Oo.
So, good morning, classmates. Good morning, sir. Today, we're going to discuss about the chromatography. So, here is the outline for today. We'll talk about the definition and the major types of chromatography. We have the plane and column chromatography. Under the plane, we have the paper and thin layer. Then, under the column chromatography, we have the simple, we have the adsorption column, the partition column, then the ion exchange, and the steric exclusion column chromatography. And another type is the automated chromatography. Under that is the high pressure liquid chromatography, gas chromatography, and GC with gas chromatography. But first, ano niyo muna siya, guys? Comment kung ano yan siya na word. Hello?
Comment daw kung ano daw yan na word. Hindi mo siya pwede ma-full screen, Goddess.
Ay, sige, sir, wait.
Kung gusto niyo makitaan, Goddess, pwede magkamagkuhan sa ni kanang mag-cellphone. Kung na kay cellphone.
Apo, sir. Okay, very good chromatography.
Okay. So lahat na ba nakapag-comment? Dapat mag-participate ha. Gina-check ba yan ako isa-isa kung nag-participate ba, Jude?
Kabright oy, very good. Okay. Thank you, classmates. Now, let's proceed. So, let's define chromatography. Ay, wala pa dahil. Pictures muna sa chromatography. Yan yung mga gas chromatography, yan sila. So, definition. Chromatography is a technique for separating molecules based on the relative distribution between two different phases. So, we have two different phases. We have the stationary or non-moving phase under the influence of a mobile or moving phase.
Oh, Goddess,
And there are
Goddess.
separations.
Excuse ha. Goddess. Ay, sige.
Po,
Nain nagakante o nain nagapangutana kung wala ba daw premyo ang naka-answer og una.
virtual hug, sir.
Lisita, virtual hug lang daw muna ha.
Oh. Wala pa yung allowance.
Kaya lang sila lang sa balay, no?
Ang gani, sir. So, pwede na mag-proceed.
Sige, go.
So, they are separated based on their solubility and their interaction with these two phases. When we say solubility, it is the quality or state of being soluble, or it is the amount of the substance that will dissolve in a given amount of another substance. So, as what I said earlier, we have two general types of chromatography. We have the plane and column. Ano gani yun? We have the plane and column. So, here is the yung parang presentation for the forms of chromatography. So, under the chromatography, divided into two, we have the planar and column. Under the planar, we have the paper and thin layer. And under the column is the gas and liquid chromatography. So, ito na naman, guys? Hula, ano yan siya? Comment. Hello.
Class, paki-comment daw, class.
Very good, Ayan. Plain. It's very simple. Plain. So let's proceed. So ano itong plain chromatography? So it is a separation technique that takes place on a flat surface or plane. So ayun, from the word, diba, flat surface or plane. The separation of substances in a solution occurs based upon differences in the solubility of molecules between two phases. Right? Ulit lang, stationary phase and the mobile phase. So mobile phase, it is the moving phase, diba? Mobile, we say mobile moving. So it is often a liquid. Ang stationary phase naman, it is non-moving, maybe minute beads, polymer gel, or a paper, for example. So we have several types of plane chromatography. We have the paper and thin layer chromatography. So what is a paper chromatography? Sa paper chromatography naman, guys, we use as paper as a stationary phase, yung non-moving, and solvent as the mobile phase. The solvent moves through the paper by capillary action. Guys, alam niyo ba anong capillary action? Paki-comment below if alam. Hashtag yes, hashtag no.
Okay, so habang nag-comment ang mga classmates, may additional ako, class, ha? Yung mobile phase, class, na sinasabi ng ating reporter, no? It may be inert gas or a liquid, ha? Please take note of that. Okay? Na-discuss na ba yung stationary phase, Goddess? Wala pa?
Ano na, sir, yung non-moving?
Okay. Yung stationary phase natin, class, please take note. Please take note, class. Yung additional lang to, ha? Additional lang to, Goddess. Okay? It can be, no? It may be silica gel bound. Okay? Silica gel bound, no? That is attached to a surface of a glass plate or plastic sheet. Okay? Sige, pag-isulat, gel bound, no? Silica gel bound nga naka-attach, class, sa glass plate or sa plastic sheet. Yan yung mga stationary phase. I think ma-discuss pa ninyo,
Yes,
no? Later on.
Yes, sir. Meron.
Yes daw, yes. Nakabalad na sila capillary.
Very good. So as a review, capillary action is the ability of our liquid to flow in narrow spaces without the assistance or external force. So why does it occur? It occurs thanks to our forces na cohesion and adhesion. Alam niyo, di ba yung cohesion and adhesion? So when we say cohesion, it is where the water molecules like to stay close together, and while adhesion is the water molecules are attracted and stick to other substance. So, yun siya ang mangyari sa paper chromatography. Later, we will show you a video on how. Then, separation depends on the solubility of solutes in the solvent, the polarity of solvent, and the polarity of solutes in the sample. So, ito yung sample diagram of the paper chromatography. So, you can see here, we have the paper, and then the solvent front, and the solvent, and then the lid. Mamaya, mas ma-charring ay mas ma-tindihan niyo siya sa video. So, let's move on to the thin layer chromatography. So, dito sa thin layer chromatography naman, uses a thin layer of silica gel, alumina gel, polyacrylamide gel, or starch gel attached to a glass plate as a stationary phase, just like what Sir said kanina. And the mobile phase is a liquid solvent. The fractions in the sample are generally quite soluble in the solvent and move with it up the stationary phase by, again, capillary action. So, ang kaibahan lang nila is yung ang gigamit niya is thin layer of silica gel and sugar. So, ito yung example niya, nasa parang column siya na ano. Yun siya. So, let's go deeper for our paper chromatography. For its principle can be partition chromatography or absorption chromatography. So, bakit siya partition? Because the substances are partitioned or distributed between liquid phases. When we say partition, it is the action of parting or division. Then absorption chromatography because it is between solid and liquid phases, where in the solid surface of the paper is the stationary phase and the liquid phase is the mobile phase. Of course, the uses are the following. We have the qualitative analytical chemistry technique to check the control of purity of pharmaceuticals, analysis of the reaction mixtures in biochemical labs. Light source, the UV light method. A sample mixture is applied to a piece of filter paper. The edge of the paper is immersed in a solvent, and the solvent moves up by the paper by, take note, capillary action. So for our interference, finger oil will interfere with the solvent or solid interaction. And the paper is laid up lengthwise against the side of the beaker. So dito sa second is, the paper should not be laid up lengthwise. So bakit? This will cause fast solvent flow on the parts of the paper flowing and the beaker. So do not allow the size of the paper to touch the size of the container, as that can make the solvent run crookly. Standard use type 2 water. Let's move on to the thin layer. The principle is, again, principle of separation. Separation depends on the relative affinity of compounds towards stationary and mobile phase. Use that to determine the number of compounds in a mixture, to determine the identity of two substances, and to monitor the progress of the reaction. Light source, again, is the UV light. The method, the stationary phase is applied in the plate immediately and then allowed to dry and stabilize. Same lang sa ng procedure yung sa paper, but ang nagkaiba lang is yung gamit nila. Then, interference, you have the organic solvents present in the laboratory environment and the choice of solvents. Standard use type 2 water. Hello! Ano pa kayo guys? Nandiyan pa kayo guys? Answer na naman tayo ng charot-charot natin. Hello? Sir? Nandito pa?
Yes, okay. Oh, yes, buhay na buhay. Okay, by comment naman dyan, no? Yung sagot. Buhay ba? Buhay.
Kaya parang ako lang kasalita.
Buhay pa. That's the disadvantage, no? That's the disadvantage. Wala yung kayo makita ng mga classmate ni mo kung
Hindi, sir. Ang feeling ako kay nag-kuhan lang po monologue.
Kanina, di ba mapansin mo pag mag-kuhan ko, pag mag-next ko presentation kay magbuhat ko, okay, pag-isulat, o inana, pag-ingon ana, para feeling ko nga na kay mga classmate mo. Buhay pa daw sila, buhay pa kami,
buhay pa pala.
Sila,
Very good. Yes.
si Vanessa, Cyril, Gatinaw, Diolina, buhay pa daw sila, grabe ka. Ano nila answer? Tama ba daw ni? Tama ba na nilang answer?
Very good. Column. Yay! Ka-bright.
Pinakauna kay
Chelsea,
no? Chelsea ang mauna.
Congratulations, Chelsea. Kung sino man nauna, palaan ka ni Lord. So, column chromatography involves the interaction example of the sample mixture with a mobile phase, often a liquid or gas, while the stationary phase is a medium in the column. The sample space is placed into the column and then flows down the column due to gravity or under the influence of pressure such as gas or liquid, and separate fractions of solute are collected in reservoirs as eluate, the liquid coming through the column. So mamaya pakita pa rin kami ng video niyan guys para mas macharot talaga. So we have here an example. We have the adsorption column chromatography, which it employs a highly specific interaction of the solid by its attraction to the surface of solid particles of the stationary phase. It is also known as this liquid-solid chromatography. So later on, mas discuss pa sila. Mag-definition muna tayo. So ito yung example nga na diagram. So ang sa top is the solvent, then the mixture containing components X and Y. Then we use the silica or alumina saturated with solvent, and then ito yung eluate, the solvent flows out of the column. Si Camille, pakibasa ng definition.
So guys, for partition column chromatography, it is the solutes within the sample interact with an inert or chemically unreactive solid support medium containing a thin film of liquid absorbed into its surface. So guys, there are two partition column chromatography, which is the liquid chromatography and gas liquid chromatography. Next.
So definition muna tayo.
Yeah. So, yan guys, yung process sa partition column chromatography. So, there is the stationary phase and the mobile phase. So, separation is based on solute in practicing between the two liquid phases.
Then,
So, in ion exchange column chromatography, it is the sample is diluted with a buffer to give the solutes an electrical charge. So, yan po yung process. So, start sa... Wait, kung makita. Yan, dun sa mix of reagents, tapos, ayan, makikita niyo yung makita, wait. Yan, yung polymer beads with negatively charged functional as groups, tapos, the protein mixture is added to column containing solution exchangers, tapos, yun, magpa-process siya, and then, the proteins move to the column at rates determined by their net charge, pH being used, and with Gaussian exchange, protein with a more negative net charge move faster and a little. So, yan po yung process ng ion. Next. So, in steric exclusion chromatography, it is the molecules are separated in the column based on size and hindrance by the pores in the gel medium. It is also known the size exclusion chromatography. Also, this method of separation is unique among liquid chromatography because kasi yung procedure at relies entirely on the physical restriction of molecules moving through a packed column rather than any interactive effect. Example, yung absorption tsaka partition into stationary phase. So, yan po yung process. The mixture of large and small compounds, tapos column containing porous support, then process siya through mobile phase, then yun. Yung large compounds is excluded from support pores. Lagi po na-exclude yung large compounds. So, yan.
So let's go deeper into our adsorption column chromatography. So its principle is based on the competition between the sample and the mobile phase for absorptive sites on the solid stationary phase. Uses used for separation of hemoglobin types such as glycosylated hemoglobin. Take note that liquid solid chromatography is not widely used in clinical laboratories. Bakit? It is because of technical problems with the preparation of a stationary phase that has homogeneous distribution of absorption sites. But yun nga, ginagamit pa rin siya minsan for hemoglobin types and for light source UV light. Method employs a highly specific interaction of the solute by its attraction to the surface of solid particles of the stationary phase, interference, organic solvents present in the laboratory environment, and the choice of solvents. Standard use type 2 water. Next, partition column
So in
chromatography. Camille.
partition, the principle is the method of separation in which components present in the mixture get distributed more likely into liquid phases. So because the individual solutes are isolated based on the different partitioning coefficients of each compound in the two-phase system. The uses is the separation of compounds containing chemicals and the determination of compounds in biological samples. So the light source is UV. The method used is the molecules containing polar and nonpolar groups in aqueous solution are added to an admissible organic solvent. After vigorous shaking, the two phases are allowed to separate, and then the polar molecules remain in the aqueous solvent, and the nonpolar molecules are extracted in the organic solvent. So this results in the partition of the solid cycles into separate phases, which is the method, the stationary and the mobile phases. So the interference of partition column chromatography is the reagent that is highly fluorescent and may interfere in the chromatogram. And the standard use is the type 2 water or purified water. So in ion exchange column chromatography, the principle is the molecule separated on the basis of their charge are eluted using a solution of varying ionic strength. And the uses for this is for the separation and purification of charged molecules and the purification of blood components such as polypeptides, proteins, polynucleotides, and nucleic acids. So the light source of this is the UV invisible light observing. Next is the method is before ion exchange chromatography, it can be initiated and it must be equilibrated because the stationary phase must be equilibrated to certain requirements that depend on the experiment that you're working with. So once na equilibrated na siya, the charged ions in the stationary phase will be attached to its opposite charge in exchangeable ions. So this interference is there is buffer requirement so it can prevent binding of the protein of interest to the column resin. The standard use is the type 2 water or verified water. In steric exclusion chromatography, the principle is used to separate solute molecules on the basis of size and shape. So the uses is used for quality control such as to identify the differences in properties of polymer and also identify the differences in properties of polymers such as protein, cellulose, and nucleic acids. Also, it's used to examine the stability of natural organic matter in water. And the light source of this is scattered by a polymer solution. In steric exclusion chromatography, the method is a sample containing different size molecules moves down the column dissolved in the mobile solvent. Because small molecules enter the pores and in the packing and momentarily matrap man sila. So large molecules are excluded from the small pores and so move quickly between the particles. So, ayan. The interference is the particles in solution do not have a fixed size. The stationary phase may also interact in undesirable ways with the particle and influence retention times. So the standard use is type 2 water or purified water.
So thank you, Camille. So ayun guys, let's move on to another topic. Can you guess the word? Guys, comment down sa next natin na topic. Can you guess the word?
Excuse me, guys.
Yes, sir.
Tapos na kayo sa column, no? Tapos na ang column.
Meron pa, sir. Yan, sir. Kaya
Meron pa.
meron pa. Opo.
Tapos na kayo sa column. Okay, sige.
Okay, very good. We have here the automated. si Frances Kairos' car.
So,
Your turn.
okay. Automated chromatography provides more specific and sensitive results than simple column chromatography. Detailed protocols for collection, handling, and documentation must be followed when testing is for clinical purposes. Okay. So under chromatography is high pressure liquid chromatography. It is a type of column chromatography, but rather than relying on the force of gravity to move the samples and mobile phase through the column, it utilizes pressure to force sample through the column. So detection of the separated compounds is achieved through the use of absorbance detectors for organic compounds and through conductivity or electrochemical detectors for metallic and inorganic compounds. So ayan yung ano guys, yung high pressure liquid chromatography. And then next. So gas chromatography naman utilizes an inert gas, often helium, as the mobile phase to move a sample through a column. So when the sample is injected into the column, the organic compounds are vaporized and moved through the column by the carrier gas at different rates depending on differences in partition coefficients between the mobile and stationary phases. And then after the gas exiting the column is passed to a suitable detector. So gas chromatography with mass spectrometry is an analytical method that combines the features of gas chromatography and mass spectrometry to identify different substances within a test sample. It is also the gold standard for forensic substance identification. Ito naman yung kanyang dyan yung injector and then hanggang after, halos same lang sila ng gas chromatography, pero ang dito lang is meron siyang, after niya maglabas doon sa gas chromatography, magpunta siya doon sa MS. So, sa HPLC, the principle is qualitative results and quantitative results. So, ang uses niya is for forensic science and pharmaceuticals. The light source is deuterium lamps. For gas chromatography, GC generates output that can be used to calculate retention time and peak area. For the uses, same lang, pharmaceuticals, cosmetics, and even environmental toxins. So light source is also deuterium lamps. For HPLC, the method is fractions of separated solutes are commonly detected using UV spectrophotometers. So interference, contaminated water, and organic solvents. The standard used is type 1 water or ultra pure water. For general sensitivity niya is pwede na yung type 2, and then for high sensitivity is yung ultra pure. For gas chromatography, method is it utilizes an inert gas, often helium, as the mobile phase to move a sample through a column. Interference is inadequate levels of carrier gas and incorrect column temperature. Standard use is type 1 water. For GC with mass spectrometry, principle is the GC works on the principle that a mixture will separate into individual substances when heated. The heated gases are carried through a column with an inert gas. Uses for criminal forensics, law enforcement, chemical engineering, medicine. Light source is deuterium lamps pa rin. And then the method is the difference in the chemical properties between different molecules in a mixture and their relative affinity for the stationary phase of the column will promote separation of the molecules as the sample travels the length of the column. For interference is medication and poor sample preparation. So standard use is still type 1 water.
So, yun lang ba't video guys.
Ha?
Ano kami ng video, sir? Maipa-play na video.
Okay, sige, sige. Okay, class, habang nag-prepare yung classmate natin, class, so I have another question, class, ha? I have another question. What type of chromatography, class, ha? Hindi pala siya chromatography. So what type of test, class, that can detect 20 inborn error of metabolism from a single blood spot? Okay? So it can detect 20 inborn errors of metabolism from a single blood spot. What type of test it is? Okay? So class, as you can imagine or as you observe, class, anak ang bata, maanak ang isa ka bata class within 24 hours, dapat class na natay ginatawag na newborn screening. So, unsa tong test, no? Unsa tong test na ginagamit para class ma-detect ang mga inborn error of metabolism. Yun. May nakasagot na MSMS or tandem mass spectroscopy. Okay? Tandem mass spectroscopy. Yun, very good. Okay. Sige. While waiting to your classmates, class, I have another question. Class. Okay? So what are the 5 separation mechanism used in your liquid chromatography? Okay? What are the 5 separation mechanism used in your liquid chromatography? Gades, okay na kayo, Gades?
Yes, sir.
Okay. So wait lang.
Makita yung video, sir.
Wait lang. Kasi magkuhan muna tayo, mag-select muna tayo ng next reporter. Sana yan.
Okay po, sir.
Okay? Yun, Nephelemetry. Okay? Next reporter, class. Pakiulit daw yung question, sabi nila. Ang question, class, what are the 5 separation mechanism used in liquid chromatography? Ito yung mga reporters natin. Ito yung mga reporters, si Folio, Gatinaw, and Ngaw. Okay, ito yung mga reporters natin. Sige. Okay, class. May mga nakasagot na, class. May nakasagot na. Para uniform tayo, class, ha? Para uniform ang sagot natin, class. Please don't forget this. Okay? Okay, so ito yung mga common. Okay, these are the 5 mechanism, no? Separation mechanism used in liquid chromatography. Okay, number 1, class, is your gel permeation or gel filtration, size exclusion, molecular sieve chromatography. Number 2, your ion exchange chromatography. Number 3, partition chromatography. Number 4, affinity chromatography. And number 5, class, don't forget your Adsorption chromatography. Okay? Your partition chromatography class, also known as your liquid-liquid chromatography. Okay? Sige, class. Class, I have a question, class. I have a question. Meron pa pala akong isang question. Saan na yun? Nawala na yung question ko. Okay, ito yung question ko, class, ha? In your paper chromatography, what is the most commonly used brand, no, of as a sorbent? Okay, what kind of brand? Okay, brand, a brand sa paper chromatography ang mostly nga ginagamit, brand of paper. Okay, sige, sa nga klaseng brand yun, kambal ang nakasagot. Okay? So, ano pang iba? Meron pa bang mga sagot dyan? Okay, so, the most common brand na ginagamit, no, is your Wattman paper. Please take note of that, ha? Don't forget the Wattman paper. Okay? Please don't forget your Wattman paper. Okay? So, that is the most commonly used brand, ha? Brand in your paper chromatography. Class, don't forget also the GCMS or the gold standard for drug testing, your GCMS or gas chromatography mass spectroscopy, okay, or spectrometry, okay. So the principle is based on the fragmentation and ionization of molecules using a suitable source of energy, okay. Yung iba answer is MCGC. Oh, sige. MSGC. So, dapat GCMS. Okay? Base ang mga answer ha. Magkabaliktad-baliktad. Sige, don't forget those important notes. Okay, sige na. Yes.
Okay, sir.
Yan.
Marinig yung audio.
In this lesson, we will learn about paper and thin layer chromatography, both of which are used in forensic science applications. Chromatography is a separation technique, and this will be demonstrated using heat coupling. Using a pencil, draw a line at the bottom of the strip of chromatography paper.
Gades, pwede mo din isend Gades ng video dito, Gades.
Yes, sir.
And repeat with green and blue heat coupling. Place this in a beaker with water, ensuring that the water level does not touch the spots. As the water is absorbed, it separates the multiple components of the heat coupling. We have now created the heat outlet. The chromatography paper is called stationary phase as it spins put. Water is called mobile phase as it moves up the chromatography paper. Here's the key idea. A component that is more soluble in water travels a greater distance up the chromatography paper, and the less soluble component travels a shorter distance. The retention factor, or RF value, is a measure of the distance that a separated component has traveled compared to the distance that the solvent, in our example, water, has traveled. These distances can be measured using VR. What does the retention factor value tell you about the solubility of the separated component in the object solvent? Please pause the video to compare this and resume when you're done. A larger retention factor value means that the component is more soluble than solvent. A smaller retention factor value means that the component is less soluble than solvent. Thin layer chromatography, or TLC, works in exactly the same manner. Instead of chromatography paper, glass plate with a thin layer of silica gel or any other absorbent material is used. This thin layer of absorbent material is the stationary phase. A suitable solvent may be used as a mobile phase. If the separated components are colorless, the dry chromatograph may be sprayed with anhydride, which can turn some components purple, or a chromatograph may be used white. Anhydride is used to detect fingerprints in the crime scene. These chromatography methods can be used to identify and compare samples of drugs, inks, lipsticks, saliva, and explosives, just to name a few. In conclusion, paper and thin layer chromatography are used to separate components of a mixture based on their solubility. The relative solubility of the separated components can be determined by calculating their retention factor values. More soluble components have a larger retention factor value, and less soluble components have a smaller retention factor value.
Tapos may isa pang video na last time.
Class, habang nag-prepare ang ating classmates, okay? I have a question, class, ha? Kung ang DCMS ginagamit as our standard for drug testing, ano naman ang para sa drug screening? Okay? Sige, pag-isulat naman. Okay? I-comment, no? Pag-i-comment naman yung sagot sa ating comment section. April, kumusta?
Here, one for biochemistry basics here.
Marinig ako, sir. Hello,
Yes,
sir.
marinig ka, marinig.
Marinig po. Delay man good sa amin, sir.
Marinig ka, marinig.
Ang loading ng YouTube, sir, ba? Mahirapan din makapasok sila Camille at Minyaw,
So, ang
sir.
question, ito yung question ko, ito yung question. Sige. Ano po, sir? Oh, yan, sagutin ninyo yan habang nag-prepare ang ating report, ang ating mga reporters. So, may question ako, ha, kung ang CMS ginagamit as gold standard for drug testing, ano naman ang para sa drug screening?
Sir?
Yes? Okay na, Gades? O, sige. Sige yan.
Yes, sir.
Okay.
Makita yung video, sir.
Ah,
Kita yung screen.
Here, one for biochemistry basics here. Let's talk about column chromatography. Column chromatography is a chromatography technique in which separation is carried out in column. The column is filled with a stationary phase, which can either be silica, alumina, or cellulose. The bottom of the column is packed with cotton or glass wool to support the stationary phase. The column preparation is usually carried out by two methods. Number one, wet method, and number two, dry method. In wet method, the stationary phase is mixed with a mobile phase to make a slurry and then packed in the column. In dry method, the powder of stationary phase is directly added to the column. Once the powdered stationary phase is packed, the mobile phase is flushed in the column to make it wet. Now, any of the method can be used for column preparation. However, care must be taken to avoid any bubbles in the column while packing the stationary phase. Let's see the working of column chromatography. The sample is loaded with the mobile phase on the top of the column. Once the sample is loaded, the mobile phase is continuously passed to cause separation. The mobile phase moves down the column because of gravity. Separation of molecules occur due to their differences in interaction with the mobile phase and the stationary phase. For example, the green molecules interact more with the mobile phase and moves fast down the column, while the dark blue and the violet molecules interact more with the stationary phase and hence move slowly. To increase the flow rate of the mobile phase, a pump or pressurized gas like argon or nitrogen can be used. Once the separation is completed, the samples are usually collected as fractions. The mobile phase leaving the column is known as eluate, while the sample molecules leaving the column is called eluite. Now, depending on the type of stationary phase used, there can be several types of column chromatography. If the stationary phase is adsorbent material like alumina or silica, then it is known as adsorption chromatography. If the stationary phase is ion exchange resin, then it is known as ion exchange chromatography. If the stationary phase is attached with a ligand that binds a specific molecule such as protein or enzyme, then it is known as affinity chromatography. And if the stationary phase is a porous gel or bead, then it is known as gel permeation chromatography.
Yan lang po, sir. Kamsahamnida. Thank you, sir.
Okay. Hello everyone! Yun, nandito na ang mga reporters. Camille
Hello,
and
sir.
April. Sino pa? So, thank you so much. No? God bless, thank you for that. So, lahat na ba naka-answer sa akong question? Aha. Bakit yung iba wala pa? Class, the correct answer, class, is yan. Paper and thin layer chromatography. Okay, TLC. Thin layer chromatography, class, used for your drug screening. Okay, drug testing, ha? Screening test. Drug screening test for drug testing. Okay. Okay, pwede din, no? Rapid immunoassay. Pero class, rapid immunoassay. Pero class, pag pinag-uusapan ang chromatography, TLC. Okay, thin layer chromatography or pag immunology, rapid immunoassay. Pero ang tamang sagot, class, is your kung sa LCMSMS. Okay. Sige. Okay, class, I think the time is 11:14. So, pwede kayo muna, class, no, bago tayo mag-start ng ating reporting, pwede mag-lunch muna kayo. Okay? Pwede kayong mag-lunch muna. Kayo. Okay lang ba? Diretso-diretso ang atong klase.
Okay lang, sir.
Sige daw, paki-comment, break muna. Or reporting. Or padayon. Sige. Comment sa comment section, break muna or padayon. Pag humana to break, diretso-diretso na ta. Okay? Okay. Sige, class, bago ta mag-lunch, mangita sa taog, mangita sa ay magpili sa kudaan o ato ang unsa ang mag-icebreaker bago ta mag-start. Okay? Sige, mag-icebreaker sa ta bago ta mag-start. Wait lang. Unsa ang mag-icebreaker bago ta mag-start? Yan, si EY. Okay? Sige. Okay, so, open ko lang to class yung streaming natin. Then, balik lang kayo later on, ha? So, mga 20 minutes. Okay? 20 minutes na mag-break kayo para diretso-diretso na ang that's it. Okay, class, break muna kayo. Salamat.
Thank you, sir.
Okay, so prepare muna kayo, ha?
Opo.
Hello, class. Marinig niyo ako? Marinig niyo ako? My God, hindi na po ako nag-istorya ba? Lenny, madunggan ako, Lenny.
Madunggan na, sir.
Ay, my God, hindi na po ako daghan kayong istorya, promise. Wala may nag-react, wala may nag- Tinood lang, gaghan na kayo kong istorya, layo na kayo kong istorya, baw niya. Sus. Okay, balik. Okay, balik na sa chika. Okay. Ikaw lang gid among gihulat ni Ian ha, kay gihulat na ka na mo mahuman og hugas. Kasi ikaw mo report sunod. Yan, okay. Kan ba yan nagpa-regard sa mga kuan, sa mga medtech, daghan nag-PM sa ako ang mga pangalan sa mga nasa front. Na sila kuan daw kisa daw tong taga-Alabel na available. Nako naa si Lenny. Yung stalker ni Lenny.
Hindi naman siya available, sir.
Ha?
Reserve na yan siya daw.
Okay, actually nagapaminaw siya dire nagapaminaw siya. Ang buka ko naminaw PM na ako to nagapaminaw ba ni siya. Reserve kay kinsa na siya reserve.
Kay kinsa daw, Len.
Engineering, sir.
Engineering,
Ala,
sir.
Joke lang. Kasi kailan ako mo ni siya akong kuan mo yun di ba? Mao ni siya akong ka-chat karon, engineering.
Kinsa na, sir?
Correct. Nangutana siya sa ako, hala sir, estudyante din mo si Lenny. Isa Lenny, taga-Alabel na ano,
Halinoy.
Student sa Lenny, no? Student.
Kinsa na, sir?
Secret. Sige na lang, unya na lang, bukol na siya. May issue, imbis nga, sige, country, wala na. Ikaw, sige, endorse og kuan sa imong mga estudyante, ha? Okay, anyway, class, a short advertisement, class, no? Advertisement brought to us by NDDU. Okay, available na po ang ating reference book na si TITS, no? Fundamental of Clinical Chemistry, available na po siya. Pwede na po siyang makuha sa bookstore. Pwede mo gawas class, pwede man yung sugon inyong mga ginikanan or naaman tayo natay tigpensan. Pwede mo sila sugon. I don't know kung pwede man siguro. Any idea? Okay? So I think ready na. Kisa ganitong sa to, mag-entertain. Kisa ganito si Ipa ba to? Ini kinsa ganito mag-entertain sa to bago mag-start. Hello?
Wala ko balik.
Si EY, yan, EY. Si EY tayo, oo. Sige, nakasulod na baka EY? Sulod ng EY. Sulod. Okay. Sige, lahat ng mga nakapasok sa StreamYard, please turn on your camera para makita mo sa mga audience. Ingon ni Kihana Rojero, Olen, hantod September 13 pa ata ni, Ano ba pasabot niya?
Nag-ask ko, sir, kung lockdown pa ba?
Okay. Oo. Chelsea, taga-asa na ka, Chelsea? Taga-asa ba ka, Chelsea? Si Kihana, taga-Alabel po na si Kihana? Yan. Mas best talaga kay Ma'am Lapian kayo mag-ask. Okay? Kasi siya yung alam kung ano yung mga method of kuan. Yun. Paki-turn on lahat ng mga camera yung nandito sa front para makita naman kayo. Basi mahalin, no? May mahalin dire, ah. Okay, ladies and gentlemen, lahat ng mga audience namin dyan, ito yung mga available.
Online shopping.
Available, yan. Marami na tayo class. Actually, at up to 10 person ang pwede makasulod kaya nag-upgrade ko og pro. Basic ay katungkuan lang, bato-bato lang, di na itong mahal kayo. Bula, sir. Ay, taga-bula man tayo si Kiana. Binako asag yun. Yan, okay. Smile naman kayo dyan. O, asa naman si Crystal, eh. Ano si Crystal? Hindi naman daw siya available. Add to cart po si Ayan Amugis. Oh, add to cart daw. Okay, sige. Ann EY, it's your time to shine. Ann EY, it's your time to shine. Okay, bago tayo mag-start, Ann. Sana yan si Ann EY. Yan. Hello, Ann. Kamusta ka? Please unmute your mic. Wala si Ann. Yan na gani. PM lang guys. Oh, PM lang daw kayo kay Francis. Cart, marunong ng gawaing bahay. Oh. Pamain kay Ian. Pamain kay Ian. O, Ian, may nagmain na ha. May nagmain na sa'yo, Ian. Okay, class, habang hinihintay natin, class, no? Habang hinihintay natin yung classmates ninyo, class, okay? Habang hinihintay natin yung classmate nyo, class, please answer this question, class. Pakisagutan naman tong question ko, class. Okay? Sige, class. Okay na? Ready na? Sige. Pakisagutan yung question ko, class. Sige. Okay, kanina lang para sa yon. Balik-balik na lang ni siya question. It is used for drug screening. Okay? Anong type of chromatography that is used for your drug screening? Okay? Di ako mag-base ng attendance ha. Okay? Sige. Ang sagot. Camille, ready na kayo, Camille? Ready na ang presentation ninyo, Camille? Anong type
Paano namin ma-screen share, sir?
Ah?
Paano po namin siya ma-screen share?
Ba may makita ka diyang screen share. Ito, screen share. May makita ka dyan sa baba.
Cellphone naman gud siya, sir. Mga ano na siya dire?
Ay, cellphone ka lang. Send mo na lang yung presentation mo sa akin. I-send mo na lang yung presentation
Opo,
sa
sir.
GC. Ako na lang ang mag-kuhan. Ako na lang.
Ay,
Yun.
hala. Sige, sir. Thank you.
Sige. Hala, bakit GCMS ang sagot? Bakit GCMS?
LC,
Oh,
sir.
bakit GCMS? Di ba sabi may screening? Na. Okay, class, pag sinabing screening ha, pag sinabing screening class, don't forget class kasi maraming nagmamahal kaayan. TLC, Tender Loving Care, okay? Thin layer chromatography. Okay, TLC class ha, don't forget TLC. Okay, for our attendance class ha, for our attendance, sulat hashtag TLC, okay? Hashtag TLC. Yan. Kaya hindi makakalimutan lasa kay basi magawa sa inyong exam, dili mo maka-answer. Okay, so send ni mo, Camille, sa group chat. Sige, ako na lang ang mag-prepare. Yan, TLC. Okay, very good. April, marinig mo ako, April? Hanggang ka mo, April?
Choppy kaayo, sir.
Iyan, sabi ko kayo, Iyan?
Yes, sir.
Hala, oy, naunsa naman ni atong connection. Oy, my God. Na si Vanessa, ginasunlog ko ni Francis Ian, sir. Channel. Okay, sige lang, nawalang internet. So, mo ni ato ang struggle karon no, atong internet connection. Sige lang, pumabot na itong dito, click ko, mamalhin ta dito. Camille, nasend ko na ba yung PowerPoint? Kahit sa GC na lang natin, Camille. Dito mo na lang isend yung PowerPoint presentation. Crystal, ikaw na lang sa mag-entertain sa imong mga classmate, Crystal B, kaya habang hinihintay natin yung mga kasamahan ninyo. Crystal? As ang entertainer of the day,
Unsa sir, dili ko kasabot.
sa i-entertain.
Sir, pwede i-comment.
Okay, comment ko na. Sorry ha. Yun na. Entertain your classmate. Crystal, nadunggan ni mo, nakita ni mo. Oh, nawala. Nawala. O si Lenny May na lang. Lenny May, ikaw na po, Lenny May.
Sir, wala ko bala sa himuon.
Kanang sa ni, kanang pag-joke ba, pag-joke.
Go, Len. Awkward na. Oy, dako kayo kung namon.
Okay, para makita ka sa to imong stalker, Balen. Lenny,
Mag-quiz na lang mi, sir.
Lenny.
Sir? Sir? Sir?
Hello, Lenny.
Sir?
Shout out mo yung stalker mo, sabihin mo, oh, kung sino kang stalker ka, dyan ka lang.
Sir, kintaman na. Sir, ba sino yung masuko, sir ba? Char!
Oh, sure. Kasabay daw mo siya permi mag-uli. Kung mag-ulig alabel.
Sige,
Okay na? Naghuna-huna gina si Lenny Bakinsa mo na, uy. Engineer man kaya, engineering student?
Sir, driver naman ako sabay.
Hala, ay gisa man ni Chelsea pinagpalit sa mas malapit. Ay, iba man po dahil ni ilahang topic dari, oh. Oh, Len, sabi ni Josel, Len, imong mga hugot. Para to sa stalker, ha? Kung sino ka mang stalker na yan na nakikinig dito, para to sa'yo.
Sir, joke lang na mo, sir ba?
Sige.
Sir, wala, sir.
Sige.
Ano, akong naman.
Len, sige na.
Unsa ko himuon? Katong best in
Katong
math.
best in math, good daw, Len. Hala, kinsa dai na siya, Len.
Best in math. Close ba di sila ni sir?
Best in math daw, Len.
Dili na ko
Ingon ni
i-mention ang
Cyril.
iyang name. Dili na ko i-mention iyang name.
Sir, nga ng close man mo. Sir.
Of course. Okay. Kung Sino ka mang stalker na yan na nakikinig ngayon? Ito na si Lenny, oh. Anong close daw ta? Ah,
Kinsa
sige
na
na, Lenny. Yan mo na ng hugot yung stalker mo.
Hugot. Hoy, wala ko hugot. Diyos ko, Lord. Josh, tabangin ko, Josh. Michelle!
Ikaw lang lagi, ikaw, Rabi, na ay ka-char.
Buangit na si Zyril, sir, oy.
Taga-asa din na imong crush nga engineering. Taga-alabel pod na siya, Lenny.
Taga Jansan. Tupad sa The
Oo.
Bricks. Sir, dako asa kong namungoy. Wala ko.
Wala, ma-hurt daw siya kasi
Oh,
taga-alabel daw yung na-crush sa'yo. Bakit daw, Jensen? Sige na, uy, Lenny. Sige na, uy.
Oh my gosh, yung unsa ko ihugot. Ilan imong mga hugot. Unsa nga hugot? Oh, sir, promise wala ko joke. Yun na.
Siya na lang. Pick up lines.
Pick up lines, Len. Katong giingon nimo tong...
Ito unsa?
Wait. Akong i-search.
Lenny, may nag-ask na daw kay Uyab.
Wala, sir. Bawal.
Oh, bawal pa daw ha. Kung sino yung stalker na yan ha, bawal daw. Wala pa daw
Sir,
si
but...
Uyab.
Unsa kaya na? But ba, sir? Unsa ni?
Sige na, Lenny.
Ano na lang.
Oh, sige.
Ha? Sige, hulaan ninyo. Ano ni siya? Blood analytes? Or pwede po siya sa urine. Basta. Nasilawan ka lang sa iba na wala ka na.
Char! Oh, yun! Oh.
Nasilawan ka lang sa iba na wala ka na.
Oh.
Murag ex man ako na, Len. Char!
Sige na, ano ni siya? Kailangan ni siya special handling pag i-prepare siya kay para dili siya ma-convert into something.
Yes, oo. Galing-galing nun.
Tama! Bilirubin.
Robin.
Nasilawan ka lang na wala ka na. Kaya ma-convert siya into...
niya na nakikinig ngayon.
Oh, sige, ayun na lang. Sige, yun lang, sir. Thank you.
Okay, so thank you so much, Lenny. Thank you so much. Yan. Okay. So, iba talaga pag may mga stalker, no? Maraming inspired. Asa naman tong uban nga mga classmates ninyo? Uy, wala lagi sila nag-reply. Okay. So, Lenny, ka na putol-putol bagihapon ko. Putol-putol bagihapon. Dili na.
Okay na, sir. Pero usahin lang maghina siya.
Oo, no? Nephelemetry. Download ko muna itong PowerPoint nila. Yan. Sige, nandito na ba ang mga reporters? Yun ang answer. Bilirubin. May ako si magnakaon, Lenny. O, yung si mong pagkaon na.
Sir, tag-piso lang din sa tindahan.
Yan. Okay, so ready na yung mga reporters natin, ha? Ready na yung mga reporters natin. Okay, sige. Thank you so much, Lenny. Yan. Kung ready na ang lahat, sulat naman dyan, #Nephelemetry. Yan. Okay, #Nephelemetry pag ready na. Camille and Miniao Gatino, are you ready? Saan si Miniao? Nandito na ba si Miniao? Yan, okay. Sige.
Yes, sir.
Ready na, sir.
Marinig, sir.
Miniao Gatino, are you ready? Saan si Miniao? Nandito na ba si Miniao? Yan, okay.
Okay, so, good noon. Madunggan ba kami?
Opo. Yes, me.
Kay ano na siya nga part to? Kay Julina.
Hello, marinig po.
Julina?
Marinig, Kams.
Hello?
Hello?
Go na
Marinig,
ta.
marinig.
Sige, sige.
Naaday ko ano,
Delay man good
naadaw
ko, sir.
sa mga classmate. Sir, pa-icebreaker si Miniao. Nag-practice na siya joke gahapon.
Hangon
O,
ka.
Miniao, icebreaker daw muna.
Ayaw, ayaw to ko, sir. Wala, sir.
Sige, later na lang
Sir,
after the
wala
presentation.
man, sir.
Sige, later, after the presentation. Sige.
Sige, sir. Mag-start na ko, sir. So, good afternoon, everyone.
Good
We are the
afternoon.
group of Nephelemetry.
Yes.
So, for the introduction, first, when electromagnetic radiation strikes a particle in a solution, some of the light will be absorbed, some are transmitted, and some will be scattered or reflected. So those are the forms of scattering, yung absorbed, transmitted, tsaka ang scattered. So next here is the amount of light scattered is proportional to the concentration of insoluble particles. So meaning same lang sila. Next po, sir. So we have here the Tyndall effect. So Tyndall effect is the scattering of light by particles in a colloid or suspension. And it is also used to determine whether a mixture is a true solution or a colloid. So makita nyo dyan sa picture, meron tayo dyang true solution and yung colloidal na solution. So when we say colloid, siya yung malalaman mo na colloid yung ang substance when there's scattering of light, and it is because dahil sa dispersed particles. And when we say true solution, there is no scattering of light because particles are too small to obstruct the light as it passes through. So, yung light scattering, naga-depend yan siya sa wavelength. So, pag longer yung wavelength ng light, it is more transmitted. And kung shorter yung wavelength ng light, it is more scattered or reflected. Next po, sir.
Tama ba to? Tama to?
So, continuation. Nephelemetry is used in clinical laboratory since it is relatively easily automated. And also, nephelemetry is a technique used to measure the scattered lights. So, ang gina-measure lang ng nephelemetry is yung scattered lights or yung intensity ng scattered lights. So, based sa na-research namin, yung amount of scattered light daw is usually determined by collecting at the right angle or 90 degrees. And also, ang nephelometry, para siyang florimetry din kasi gina-measure din ng florimetry yung scattered light at the right angle of 90 degrees. Next po, sir.
Next slide po, sir.
Next slide na.
Opo, sir. So, the
Diba?
principle
Yung sa
of
principal sa kanya, sir.
Ayan. Principal naman. Dili ni Mao.
Sir.
Isa pa? Isa pa?
Marinig ako, sir.
Marinig ka.
Sir, hello.
At 90 degrees to collect the
Marinig ka, Joy.
Marinig ka namin.
Hello, everybody.
April, marinig ka namin, April. We can hear you. We can hear you.
Wala kasi yung connection, sir.
Sige lang, okay lang yan. Okay lang yan. Just keep going.
Yeah. The principle of nephelemetry is a technique used in immunology to determine the levels of several blood plasma proteins. In addition, nephelemetry is the detection of light energy scattered or reflected toward a detector that is not in the direct path of the transmitted light. So, next, sir. Next slide po, sir. Sa theory na, sir.
Theory na. Actually, theory na yung slides.
Ay, wait. Loading pa kasi, sir. Hindi ko makita.
Sige, sige. Okay lang yan.
Sa phone na lang ako magbasa, sir. Sige, sa theory, lesser concentration, uniform scattering, intensity of scattered light, proportional to concentration measured at 90 degree. Then, nephelometry can be used to detect either antigen or antibody, but is usual run with antibody as the reagent and the patient anti-agent as the unknown. So, merong two types of test here, which is the endpoint nephelometry, next slide, sir, and the kinetic. So, in the endpoint nephelometry, tests are run by allowing the antibody or antigen reaction to run through Hello, sir.
Nawala si Joy.
Hello.
Naman siya.
Hello, sir. Marinig ako, sir.
Nawala
Oo,
siya
marinig
kadali,
ka
sir.
Wala ko, sir. Okay na? Hello? Hello, guys. Hello.
Okay
Okay
na,
na,
Joy.
sige. Two types of test run is the endpoint Nephelemetry. Sa two types na po, sir. Endpoint Nephelemetry and the kinetic energy. So, sa endpoint Nephelemetry, tests are run by allowing the antibody or antigen reaction to run through completion. It is until all present reagent antibodies and the present patient sample antigens can be aggregate have done so, and no more complexes can be formed. While kinetic energy is the rate of the scatter is measured right after the reagent is added. As long the reagent is constant, the rate of change can be seen as directly related to the amount of antigen present. So next, instrumentation na sir.
Next ko na.
Yes, sir. Sorry, sir. Kay logid kayo, sir.
Yan.
Okay, so we have the 4 instrumentation in Nephelemetry: lamp, filter, sample cell, and detector. So we will discuss that further in the next slide. Okay, so amo ni ang matabo sa machine ng Nephelemetry. So if you can focus dyan sa upper part ng picture, ay Jesus, we have the light source. So the lamp or light source, that is the source of the radiation. So kanang ang madalas ang light niya magpunta siya sa isa ka convex lens. Yung makita niyo jud sa baba yung lens. Ang purpose niyan is to collect the light sa isa ka point para magpunta siya sa sample cell or ang sample holder. So diyan yung sample natin makikita, and may mapapansin natin diyan sa may mga blue na mga squares. Yan yung mga pagka-scatter. Since Nephelemetry naman is the study of the scattering of light, so dyan na mismo yung mga blue nga dots. Dyan makikita natin yung mga detectors. So, i-catch niya ang pag-scatter. So, sa Nephelemetry, dyan tayo sa 90-degree na detector. Usually, may similarity siya sa turbidimetry, pero ang ang ika-catch niya na detector yung pagpa-straight, yung sa transmitted light detector pa-straight siya. Dumadunggan gapon ko. Opo.
Yes, ma'am. Madunggan ka.
Okay. Sige. Balik ta ka nang sa taas ko na nga picture kung mapapansin niyo. After ng cuvette, yung detector, spectrophotometer, turbidometry, and kung naman siya, forward scatter na direction, meron tayong kung mapansin niyo sa araw kasi yung diretso, amo na siya ang turbidometry. And kung mag 90-degree angle naman siya, amo na siyang nephelometer or nephelometry. May similarities kasi yan sila daw, yung nagaiba lang is yung position ng kanilang detector. And mas ma-explain mo niya siya further sa video nga ipakita namin after nito. Next slide ko hangyo, sir.
Okay, next na nako.
Apo, sir. Okay. So, ang light source naton, this is a white light or monochromatic light. Or pwede po siya na mercury arc, laser beam, or tungsten lamp. Ang filter naton is our visible filter. So, kani nga mga information sa mga parts, nakuha nila muna siya sa TEATS. Opo. And next slide po, sir, please. Ayan. Sample cell or the sample holder or yung sample mismo. This is the cylindrical cell, rectangular, or special cell with flat bottom. So, yung sa picture natin kanina, yung gigamit doon is cuvette. Ang ato naman nga detector, so dapat tandaan ni siya,
Ang detector naton is PMT or Photo Multiplier Detector. So, dapat tandaan nyo nga 90 degrees na siya. Basta Nephelemetry, 90 degree nga light ang ika-catch. Next slide, sir, please. Okay, so here we have the factors affecting the measurements. So, light scattering in a physical phenomenon resulting from the interaction of light with particles in a solution. So, as we have already discussed, na ang nephelemetry is the study of the ang measurement of scattered light. So, amo ni siya ang mga factors nga pwede maka-affect sa atong results, like the particle size and shape. Sa nephelemetry kasi kailangan nga super maliit or super fine talaga ang particles natin, which we also discussed sa video nga later ipakita. Of course, ang wavelength, ang concentration of particles nga dapat super diluted po ni siya. The distance of observation, molecular weight of particles, RI difference, refraction index difference. Hangyo ko next slide, sir. Okay. Si Julina na natin.
So, for the applications of Nephelemetry, first here, ang Nephelemetry, pwede siyang magamit for the analysis of water. Another is, magamit din siya sa biochemical analysis such as it is used to estimate proteins, yeast, glycogen, beta and gamma, globulin in blood serum and plasma, and also kasali din doon yung determination ng growth of bacteria. Also, it is used in the determination of carbon dioxide. It is also used in the determination of inorganic substances such as sulfate as barium chloride, ammonia as Nessler's reagent. Next is, it is also used in organic analysis such as yung clarity of citrus juices and yung presence ng benzene in alcohol. It is also used in atmospheric pollution, yung air dust and smoke na para ma-monitor siya. It is also used in the determination of molecular weight and also used in water treatment in plants, sewage works, refineries, and paper industry.
Tapos na mga slides.
Oh, wala na. Naka?
Okay, so thank you, sir. May dagdag lang ako, sir. Nagamay.
Sure. Sige.
Ano kasi, sir, I think it's important na ma-differentiate natin ang nephelemetry and turbidimetry. Kasi yan sila, always sila magkasama kung i-explain ang nephelemetry. Usually kasama din yung turbidimetry. So, and may sa isa po nga video nga gisend na kon kay may equation dito or yung solving kung paano ginahimo sa amuni nga topic. So, pwede namon ipapalitan ni sir tong video nga ara sa
Sure.
GC, sir.
Nasa nga GC, wait lang. Sa GC, kaya lang. Yung last nga gisend mo?
Nang dalawa, sir.
Okay, asa man ang unahon? Taas?
Kanang sa taas amo na siya ang may equation or nang may solving.
Monday.com and manage Oracle platform that's easy to use. Whether it's projects or workflows, you can track your team's progress visually. Anywhere.
Structure and origin of turbidimetry and nephelemetry. solution containing suspended particles, the vacuum is carried out and the reading is transmitted. This is samples. That phenomena is known as colorimetry. Radiation. Quantitative analysis. This phenomena is known as Nephelemetry. Turbidimetry and Nephelemetry involves the use of very dilute solutions. Therefore, suspended particles must have negligible solubility. Light great care must be taken that samples are free from dust particles. The particles of the dispersed phase must be very fine so that they do not settle down rapidly. At low concentrations, an equation similar to Beer-Lambert's law is applicable to turbidity measurement. Log of I0 by IT is equal to KCL. Therefore, ln of I0 by IT is equal to 2.303 KCL plus inverse I0 by IT. Ln of IT by I0 is equal to minus 2.303 KCL. Therefore, IT by I0 is equal to e raised to minus 2.303 KCL, or IT is equal to I0 e raised to power minus 2.303 KCL. Or we can write IT is equal to I0 e to the power minus JL, where J is equal to 2.303 Kc is called turbidity coefficient. I0 is the intensity of incident radiation, IT is the intensity of transmitted radiations, L is the length of the solution, and log of I0 by IT is called turbidence. If you like this video, please click on the like button and also subscribe to my channel.
Okay,
Hey,
so
may isa
sa dito
pa,
nga
may isa pa.
video,
Okay.
apo sir, yung isa rin po sir.
Yes, yes.
Light is on a solution containing suspended particles. The fraction of the light is and the remaining is transmitted. We know the intensity of transmitted. This phenomenon is known as turbidimetry. Which is the intensity of transmission, and also we can have quantity analysis. This phenomenon is known as Nephelemetry. The instrument for turbidimetry and Nephelemetry are the same one. They consist of source of radiation. This can be any ordinary lamp, collimating convex lens to collect the radiations coming from the source. Then there is sample holder or cuvette. After that, again there is a lens to collect the transmitted radiations, and then finally the photocell or readout meter. In case of Nephelemetry, the collimating convex lens and the photocell are placed at 90 degrees to collect the scattered radiation and avoid the transmitted radiation. Source is placed exactly at the focus of the collimating convex lens. The transmitted light from the lens is traveling parallel to the principal axis. This light is then incident on cuvette or sample holder, where sample solution is placed. Highly monochromatic beam is not necessary. The beam is scattered by the particles in the sample, and the transmitted beam is less intense than the incident beam. The transmitted beam is allowed to fall on the photoelectric cell. The current is produced. It is connected with the readout meter or dial, which gives turbidence directly. In case of Nephelemetry, the scattered light at right angle to the incident is allowed to fall on the photoelectric cell. The current is generated in readout meter, and the intensity of scattered radiation is measured. If you like this video,
Sir,
please click on
papos ako sir. Pwede ako papos dito sa ano sir sa diagram.
Okay, okay.
I-reiterate ko lang. Okay, so
Yan.
Apo sir, thank you sir. Essentially, yung turbidimetry and nephelometry, the same sila ng principle nga naga-measure sila ng scattered light. Ang only difference nila is ang turbidimetry, yung light is diretso lang, parallel siya sa sample. And sa ano naman, nephelometry, gina-place ang detector at a 90-degree angle. So, yung sa baba. So, amo na nga always na sila din na sabay sa mga chapters or kung mag-discuss kay same naman sila principal lang nag-iba lang kay ang position sa pag-catch nila sang light. That's all, sir. Thank you.
Okay, thank you so much. Mga reporters, no? Si Camille, sino pa yun? Si Julina Miniao and kisa pang isa gani?
Si April, sir.
Okay, wala na siya, no? Miniao, saan ka Miniao? Before we move on to our next, okay, before we move on to our next reporter, please prepare Miniao ha para entertain mo mga classmates, okay? Okay, class, please don't forget class ha what we call the principle of your Nephelemetry, okay, determines the amount of scattered light. Please don't forget that. The keyword here is scattered light by a particle matter suspended in a turbid solution. Then class, please don't forget also that the size or the diameter of your antigen-antibody complex is 250 to 1,500 nanometer, and the wavelength used to detect your antigen-antibody complex is 320 to 650 nanometer. Okay, thank you so much. Okay, so before we move on, Minyao, please prepare for your information number. Okay, now, prepare na ha. Okay, so, mangita na ta, sa ang next nga reporter. Sige, kinsa kaya ang next na reporter? Okay. Sino kaya ang papalarin ko? Yan. Ay, human naman ang chromatography. Wait lang, tapos ng chromatography. Remove sa na ako ni. Yun, next is electrophoresis. Okay, electrophoresis. Yun. Okay. Sige. Minyaw, habang nag-prepare yung ating mga reporters, Minyaw, please, paki-entertain ang iyong mga classmates habang nag-prepare tayo ng ating presentation. Yan. Okay, palakpakan naman natin si Minyaw. Okay. Pakisulat, hashtag,
Mag-joke lang ako, sir.
hashtag Minyaw. Minyaw. Yan.
As in, sir.
Okay. Kuya langan inanami ka supporter. Anak ko ka supporter sa mga kuan supporters.
So, mag-joke ko, sir. Since, ano naman ba sa Burmans, na ako'y pangutana. Madunggan ko, sir.
Oo, alangan.
Sige, ang pangutana na ako kay, where do you keep a Christmas tree? Hoy, diyan nga dapat makadaog ko sa giveaways ni mo.
Ang naikuan,
Sige,
na
natubag na
giveaways.
mo. Si Gubat, sir.
Ang sayang giveaway,
Support daw ninyo ang Bilinabi PH.
Sige, kanata na siya, i-advertise. Sige. Dapat tagaan po nimo ha, Gubat.
Sinatubag na mo, where do you keep a Christmas tree? Asa ninyo i-keep ang Christmas tree?
Asa daw ginakip ang
Sa
Christmas
bodega.
tree?
Makatawa man ko eh. Corny man good.
Sabi ni si
Shout out kay
Sophia,
Danny Vlog.
Bilinabi PH daw. Sa dayong naadri sa kuan, Bilinabi.
Mga ano na dira, sir, mga bayo, mga keychains. Gwapo mga bayo, sir,
okay.
pang ano, pang Christmas gift din mo, sir, sa imong mga inaanak.
Dapat ang maging model natin si Miss Kuan.
Walay naka-answer.
Wala daw naka-answer. Sige na, balik ang question. Sa dapit ang office ani ni Kuan Billy na BPH.
Sirit daw. Sa ano, ang Christmas tree ginatago siya between Christmas 2 and Christmas 4. Uy, katawa mo guys. Comment mo hahaha. Sir, pwede mag-request og next mag-entertain
Sige.
si Tempo Mona, sir. Please, sir.
Si?
Thanks sa support, guys. Si Ira, sir.
Ira, di man kasulod. Okay. Okay, later na.
Last week ko na siya nag-practice.
Sige, sa kanina mga reporters nato, mga reporters are the following: Barida, Mona, and Neffy. Okay, nandito na si Neffy. Sino pa? Isa pang na-adre. Nakulban, ana pa si Kuan, nakulban ko sa among report. Ana si Ira, gikulban na daw siya. Isa na ko ang uban nga na-adre ha. Sige. Asa naman ang uban? Si Neffy, si Barida, Takan, I think na si Neffy. Si Neffy pa lang. Neffy, nanay yung PowerPoint presentation.
Kay Ira, sir. Wait lang.
Yan, yan. Pwede nyo i-send yung link, yung video, yung PowerPoint presentation niyo dito sa ating group chat.
Di daw makapasok si Chelsea, sir.
Sige, okay na. May alis na. Yan, Chelsea, yan. Nasok na kita. Isa pa. Ira, sulod na gisend na ninyo ang PowerPoint. Ira, ikaw ni si Ira Sexy. Send ninyo ang presentation ninyo, Ira.
Sir Alfred.
Si Ira si Ira Timpumona, ni Ira Sexback. Kaya magpangalan ni Ira, oy.
Sir, madunggan ko.
Oh, madunggan. Yes, inyong presentation, asa naman?
Sir, may concern ako.
Oo, bakit? Ano yun? Anong concern? Hello? Chelsea, bakit Chelsea? Anong problem? Nefi, ano yung problem, Nefi? Nefi? Nefi, kindly unmute your mic.
Sir,
Anong concern?
hindi ko alam kay Chelsea po. Wait.
Saan, ano yung, may presentation kayo? Wala. PowerPoint.
Meron po, sir.
Send mo na lang dito sa Messenger. Ako na lang ang mag-present. Okay. Baka ma-exit ako bigla kay itaod ang fiber ho. Sige lang, okay lang. Kung ma-exit, mayroon ka mang classmate na mag-represent. Sige, send na ba? Okay. Okay, prepare na. Asan na? Wala na tayong time. 1:30 yung klase, no? 1:15.
Ay! Ulagay ko yung nadunggan.
Lenny May, sa oras ang klase ninyo nga next? Lenny May, 1:15, no? 1:15.
1:45 ito matapos, sir. Ang next class namin, 2:15.
Okay. Nasaan na yung presentation, Naira?
Ulagay ko yung nadunggan. YouTube.
Send na yung presentation. Pakidugay kayo. Yung PowerPoint presentation, isend na.
Hello?
Hello.
Rang!
Send na inyong PowerPoint presentation. Entertain us, Miss Tape muna. Entertain us daw. Okay, sige, Zyril Barida, entertain mo mga classmate habang wala pa may mga presentation. Sige.
Wait lang, sir. Kaya PowerPoint.
Send ka isa ko inyong PowerPoint. Ako na lang mag-next.
Saan naman
Okay, next meeting ka sa ang inyong PowerPoint mo ang pilion, isend na sa Messenger kaya ako na mag-present. Okay, Zyril Barida, habang hindi pa kayo prepared dahil sa consequence nito, ikaw muna mag-entertain ng mga classmates mo, okay? Sige, please entertain your classmates, Zyril.
Bisa-bisa lang, sir.
Bahala ka na, magsayaw, yan.
Alay na po. Wait lang. Mag-ask na lang ko.
Sige. Dili i-off ang camera.
Wait lang! Ano? Magtanong ako ha. What can run but never walks? Has a mouth. Has a mouth but never talk. Has a head but never weeps. Had a bed but never sleeps. Riddle ba na?
Saan na ang PowerPoint presentation ninyo? Saan na? I-send sa Messenger. Malay mo answer, lisod daw, lisod. Magkanta na lang daw ka. Kanta na lang daw, lisod daw. Hindi na sila ganahan. Sing na lang daw.
Uy, bahala, sir. Magbagyo, Jud. Kailang.
Hello?
Ano wala may power mag-minus ko og pan. Minus ko grade sa inyo ha.
Sir,
Dugay
nana
yung
ko, sir. Sir, nana ko.
Si Ayra, sir.
minus ko og pan. Minus ko grade sa inyo ha. Dugay yung
Sir, nana ko. Si Ayra, sir.
Dali.
When I look at you daw, when I look at you. Sige na. Sila nag-feed ang bukaan ba? When I look at you daw, when I look at you.
Hello?
Ay, shout out daw. Oh, ana si Jan kay shout out kay Ting. Shout out. Isang admirer ni Kyle direct, isang admirer ni Kyle. I-follow na ninyo siya sa inyong channel. Jan Kyle Montero. Admirer ni Kyle direct, isang admirer ni Kyle. Tira, imo ang microphone. Ay, nako.
Tama, biya sa Lenny.
Isang answer.
River.
River daw, river. Okay?
Sa Lenny.
Sino ang naghawak ng inyong PowerPoint?
River.
Cyril. River daw, river.
Si Ira at saka si Chelsea.
Bakit hindi mo ginasend ang PowerPoint? Sino ang naghawak ng inyong PowerPoint? Cyril. River daw, river.
Si Ira at saka si Chelsea.
Sino ang naghawak ng inyong PowerPoint?
Si Ira at saka si Chelsea.
Asa na yung presentation ba? Asa na ang PowerPoint presentation?
Sir, dili na ako masal sa messenger.
Kagin sa man ang kuan.
Sir, dili na ako masal sa messenger.
Ay, nako, katika. Cyril, kinsa nagagamit sa inyong PowerPoint?
Si Chelsea, sir.
O, paminaw daw, Chingkay. Ayaw daw sigigtat sa kay Jan Kyle. Kinsa din na si Chingkay?
Si Richel Mercado.
Mercado. Ang kinachat man nimo si Jan Kyle, nga di man nimo ingon dere. Na ba si Mercado dere? Siguro ni Chingkay si Jan Kyle ba? From Tiboli. Saan na yung presentation class? Oh, grabe. Nahurot na ninyo ang 20 minutes ba? Bink na auntie. Oh, Chingkay, wala sir. Oy, charot-charot man na si Kyle. Ha, ha, ha. Ay, Chingkay, ginachat si Jan Kyle. Kinsa rin nakakas kay Jan Kyle dere. Sige daw, be, taas kamot, be, taas kamot. Ang i-hashtag, kuhan daw, Chingkay. Sige daw. Chingkay. Kinsa ang nakakas kay Jan Kyle? Hello, class. Asa naman inyong PowerPoint? Oy, di makaya sa messenger na ko kayo. Kan man ni siya. PDF. Nasa Messenger, PDF. PDF ang nasa gisend. PDF lang, PDF ang gamiton. Sige, PDF na lang. Oh, hala. Mudya ng tibuli day si Chingkay. As in, karon lang ako kabalo ba? Mudya ng tibuli day ka Chingkay. Congratulations, Chingkay. Yan.
Sir, kung gisenda ni Chelsea.
Ani siya kaning PDF?
Opo.
Ano ba si Ira? Sir, makasunod kong StreamYard pero asa ni? Academic freeze akong laptop basig unta akong joke. So ni bagsik na unta ang iyang joke.
Yes, sir.
Yeah, wait lang. Sige. Sige, ito na. Okay, ladies and gentlemen, please welcome the reporter of group Electrochemistry. Ito siya ang link sa G Drive. Send sa GC para ma-open ni Ay, okay. Ano si Andre Bovis? Tamsak muna tayo. Tamsak muna bago habang humihintay. O, yan, ito na. Na-open ko na. Ito na sa wakas. Okay, nandito na. Tapos si Vanessa de Viejo, mura na siya gata na og balita. Grabe. Balita, Jude. Okay, ladies and gentlemen, please welcome the group of Electrophoresis. Yan. Okay. Nakita na ninyo class ang presentation. Paki-comment naman dyan sa comment section na hashtag Electrophoresis. Okay? Sige. Paki-comment dyan sa ating presentation, hashtag Electrophoresis. Okay? Sige. Ian, anong masasabi mo, Ian, kay Ira Ian? Ma-inspired naman siya. Anong masasabi mo, Ian?
Kusog yung feedback ganina, sir.
Ay, Ira, kusog tayo mong feedback, ha? Kusog tayo mong feedback, Ira. Sige, sugdin na ninyo, mga reporters. Let's start.
Hello? Magdunggan ko?
Yes.
Sige, mag-start na ako. Good afternoon, everyone. For today, we will discuss about the electrophoresis. Presentation outline. First, the definition of electrophoresis. Second, principle of electrophoresis. Components of electrophoresis. Rate of migration. Support materials. Type of electrophoresis. Next, sir.
Okay na, next na.
So, what is electrophoresis? Electrophoresis is a technique used to separate macromolecules in a fluid or gel based on their charge, binding affinity, and size under an electric field. Principle of electrophoresis, migration and separation of charged particles under the influence of an electric field.
So, good afternoon, guys. Sorry for the noise. So, what are the components of electrophoresis? Marinig pa ako?
Yes,
Opo.
Chels.
Hello?
Yes, Chel.
Okay, so let's proceed. So what are the components of electrophoresis? As we all know that electrophoresis is for protein siya, di ba? So first is the electric power. What is electric power? This is known as the power supply or the driving force. And it takes the standard alternating current available from a wall outlet and converts it into the one-way direct contact needed to set up an electric field across the gel. In short, electric power is it provides a mechanism to control the amount of force contained in the field. The voltage for the electric power that commonly used is 80 to 150 voltage, and commonly ang hours na mag-take siya is around 1 to 1.5 hours depending on the gel concentration. Second one is the support medium. So what is the support medium? Wait lang, before sa support medium, unahin ang buffer. So buffer have two properties that affect the charge of amorpholite. I'm sorry guys, I need kaso. So what is buffer? Buffer maintains the gel at a stable pH, minimizing changes that could occur in the protein or nucleic acid if subjected to unstable pH. So what is the barbital buffer? This is the general purpose of barbital buffer is that it provides separation of serum protease, lipoproteins, and isoenzymes such as lactate dehydrogenase. There are two properties of buffers. These are your pH and ionic strength. So what is pH? The ions carry the applied electric current and allow the buffer to maintain constant during electrophoresis. So, paggamit sa buffer, kailangan maging constant good ang pH niya. Di ba ang pH is given 8.6. So, the other one is the ionic strength. This is when the higher the ionic concentration, the higher the size of the ionic cloud, and the lower the mobility of the particle. In short, the greater ionic strength produces sharper protein band separation that leads to increased heat production and leads to denaturation of heat-labile proteins. Nasundan niyo pa ako, guys? Or mabilis? Hindi ako nakasigaw. Sorry, guys. Okay, next one. Let's proceed to support medium. We have different support medium in terms sa electrophoresis, pero ma-discuss siya isa-isa ni Zyril. Next one is the sample, and the last one is the detecting system. Additional information about the voltage and the electric power, how does it affect the electrophoresis? It affects the higher the voltage, the faster the DNA will travel through the gel. However, voltages that are too high can possibly melt the gel and cause smearing and distortion of DNA bonds.
Hello guys, madunggan ko.
Opo.
Hear me? Okay. So rate of migration. The rate of migration is dependent on factors such as the net charge of molecule, size and shape of particle, strength of electrical field, properties of supporting medium, temperature of operation. Electrophoretic mobility is defined as the rate of migration per unit field strength. Tapos na siya nga formula nga electrophoretic mobility equals the net charge on the ion over 6 the ionic radius of solute and the viscosity of the buffer solution in which migration is occurring. Next na. Next na po, sir.
Support materials. First, the cellulose acetate is an important technique in clinical diagnostics. These have the advantage that they can be used for a wide variety of clinical electrophoresis, including the hemoglobin, serum protein, urine proteins, isoenzymes, and glycoproteins. Second is the agarose gel. Agarose gel is a method of gel electrophoresis is used in biochemistry, molecular biology, genetics, and clinical chemistry to separate a mixed population of macromolecules such as DNA or proteins. It is one of the two main components of agar. Next, the polyacrylamide gel. The polyacrylamide gel electrophoresis involves separation of protein on the basis of charge and molecules. The gel is prepared before electrophoresis in a tube-shaped electrophoresis cell. The last one is the starch gel. The method using starch gel as a supporting medium is considered to be the most accurate and reliable for routine screening purposes of many hemoglobin. Next, sir.
Okay, may addition ako dyan ha. Addition sa ating supporting media class, pakisulat class ha, pakisulat your paper electrophoresis, okay? Pakisulat yung supporting media natin dyan, paper, okay? Papel, okay? Pwede din gamitin yung paper electrophoresis. Okay, sige. Ma-discuss nyo ba, Cyril, yung mga stain na ginagamit? Stains na ginagamit? Ma-discuss ba natin dyan? Wala. Wala?
Wala, sir.
Wala kayong stain. Okay. Class, paki-take note na lang, class. Paki-take note. Okay? Class, meron din tayong ginagamit mga stain, no? Ano yung stain? Yung stain, class, ginagamit ito, class, para makita natin yung mga bands. Ay, hindi nyo ba nalagay sa inyong PowerPoint, Cyril? Stain na ginagamit. Just like amino black, Sudan blue, wala no?
Wala, sir.
Sige. I-add ko na lang para dili sila malibog, no? Or para di sila malito. Okay, class? Pakisulat, class, ang mga stains, okay? Stains for visualization. Okay? Of fractions. Okay? So, ito, class, para sa inyong protein at saka enzyme. Okay? For your protein, okay, protein and enzyme, we have amino black. Pakisulat, amino black and Consho S. Okay? Consho S. And para yan sila, class, ha, para yan sa inyong protein and enzymes. Okay? Pakisulat, paki-memorize na lang. Next, class, is your oil red O and Sudan black. Okay? Saan kaya yan sila? Oil red O and Sudan black. Do you have any idea, class? Do you have any idea? Okay? Baliktarin. Ayan sa class sa ating mga lipoprotein. Okay? Oil red O and Sudan black. Yan, lipid. Very good. Yan. Tama, cholesterol, lipids, yan. Mali ako spelling sa lipoproteins ha. Imbes E na E, R. Okay, next class. Ay, napaday isa class. fat red 7B. Okay? Tapaday. Okay? Oil red O, Sudan black, and fat red 7B. Next class sa ating CSF. O sige, any idea class? Ano yung stain para sa ating CSF? Sige daw. May makasagot dyan. Okay? Mayroon bang makasagot dyan, class? Mayroon bang alam kung ano ang stain para sa ating CSF? Class, the answer is Kumasi blue, okay, for your CSF. Then we have also class gold or silver, okay? Gold or silver stain, class, this is used, very sensitive to siya, class, para sa quantitation of your protein. Okay, that's my additional, okay? So, move on na, move on. Is Irene? Sino ang next reporter? Ikaw pa rin?
Sir, pa-next po. Ayan. Kat.
Hello. So, for additional information, electrophoresis is a process that enables lab professionals to isolate organic molecules in research as part of biomedical analysis. So, here are some treatment and application for electrophoresis. First is the antibiotic testing. Second, vaccine testing. The third, DNA analysis. Fourth, analysis of proteins and antibodies, and so on. Additional lang po yan, sir. Next. And so on.
Next po ako, sir.
Detection and quantification, ito.
Opo, marinig ako, sir.
Oh, marinig ka nga ni Ayan. Ayan, marinig mo ba si Ira, Ayan?
Yes, sir.
Oh. Marinig ka ni Ayan.
So, for detection and quantification of electrophoresis, we have separated proteins fraction are stained to reveal their location. So, yung sabi nga ni Sir kanina na yung mga stains na ginagamit to enhance visualization of those location, we have amino black fat red 7B and other staining pa na pwede. Alam naman natin na ang purpose ng staining is to enhance visualization of microorganisms or other na para mas ma-view siya sa under the microscope. So, different stains come with different dates from different manufacturers. The simplest way to accomplish detection is visualization under UV light. So,
Hello, marinig mo ako, Ira? Marinig mo ako? Okay, class, habang hinihintay natin si Ira, class, paki-comment naman sa comment section, class, what is the meaning or ano ba ang tinatawag na iontophoresis? Okay? Iontophoresis. Habang hinihintay natin si Ira, ano bang ibig sabihin ng iontophoresis? So, let's define some terms na ginagamit sa ating electrophoresis. Ira, hello, Ira, can
sir,
you hear
hanggang
us?
saan lang po ang narinig, sir?
Ito na? Hello, Ira?
Opo, sir. Sir, hanggang saan lang po narinig kanina?
No?
Sa detection pa po, sir.
Di ba, Dere? Sige.
Sa detection pa po. So talking about staining, yung sabi kanina amino black and patred 7B, that those are examples of yung parang pang-stain to reveal their locations or locations ng microorganisms or mas ma-enhance yung visualization para mas maklaro siya under na ng microscope. So kung narinig niyo ako, pa-comment ako ng #TrueColors kasi how amazing na ang staining is yung parang maka-enhance siya or sana ma-apply siya sa mga tao kay para ma-reveal din ang kanilang true colors.
Ayan, #TrueColor. Ngayon, Ira, mag-comment kami na #TrueColor. #TrueColors daw. Sana all true colors. Ira, nandito ka pa ba? Ira. Okay, habang hinihintay natin si Ira, i-comment naman, ano bang ibig sabihin ng zone electrophoresis? Okay, zone electrophoresis. Ira, nandito ka ba?
Hello.
Zairi. Mag-next na ba ko?
Pag-next na lang, sir.
Types of electrophoresis.
So there are like madaming types of electrophoresis. This one is Sir Panex po.
Okay.
So what is capillary electrophoresis? This is known as SE and the standard use is the agarose gel. Capillary electrophoresis is used for separation, quantitation, and determination of molecular weights of proteins and peptides, analysis of polymerase chain reaction products, analysis of inorganic ions, organic acids, pharmaceuticals, optical isomers, and drugs of abuse in serum and urine. So we have a term used in capillary electrophoresis called the electrophoretic mobility. This is the rate at which the particle moves in directly proportional to the applied electric field. In short, the greater the field strength, the faster the mobility. The use of capillaries instead of a conventional slab gel makes it possible to apply a much stronger electric field resulting in faster separation and higher throughput. An application of it is the STR analysis and Sanger sequencing. These two applications are commonly used sa forensic laboratories. Diba makita nyo man yung parang diagram dyan, yung sa capillary electrophoresis. So, etong source, reservoir, and the sample are interchangeable. And ang ano niya, may two key mechanism. Tandaan nyo na may two key mechanism, pero ang pinaka-mechanism talaga ng capillary electrophoresis is called the EOF or the Electro-Osmotic Flow. So what is electro-osmotic flow? In short, EOF is the movement or direction of the bulk solution. Imagine, itong capillary tube, nakikita nyo, pag i-cut mo siya, Pag i-cut mo siya, may makita kang tatlong layer. First one is the fixed layer. The second one is the diffuse layer, and the third one is the bulk solution. Imagine na pag ang diffuse layer is like a movable tube inside the capillary. When we apply a voltage across the capillary, the cut ions in the diffuse layer will be attracted towards the negatively charged cathode, dragging the bulk solution along with them. The electro-osmotic flow is generally towards the cathode. Yun yung point sa CE. Papunta siya ng cathode. Sir, next. Please po. Sige pa po, sir. As I have said, di ba may two mechanism ang under sa CE. This is the electro-osmotic flow, and the other one is the electrophoretic mobility. But the most fundamental concept of capillary electrophoresis is the EOF. It controls the amount of tissue solutes remain in the capillary. Basta tandaan nyo lang that electro-osmotic flow is the movement or direction of the bulk solution that can be found in the capillary tube. So, for example, the UV visible detection. This is performed directly on the capillary and it widely used for monitoring separated analytes. An example, in addition lang sa electrophoresis, we have macromolecules used in clinical laboratory. These are the serum, the urine, the CSF, other biologic body fluids, erythrocytes, and tissue. Sir, next po. So under the UV detection, these are used for higher sensitivity. Below, we can see the fluorescence, the laser-induced fluorescence, the chemiluminescence detection. Okay na po, sir. Next na po. Zai, parang ikaw na, Zai.
So, okay na ba, Zairil? Dito na, gel electrophoresis.
Gel electrophoresis, a technique used to separate DNA fragments according to their size. Standard use is the agarose gel.
Paper electrophoresis, frequently used in isolating proteins, amino acid, and oligopeptides. Standard use is filter paper. This is a technique is useful for the separation of small charged molecules such as amino acid and small proteins. A strip of filter paper is moistened with buffer, and the ends of the strip are immersed into buffer reservoir containing the electrodes. Next po, sir.
Zone electrophoresis. It is an electrophoretic separation technique typically used for analyzing proteins, nucleic acids, and biopolymers. Standard use agarose and polyacrylamide gel.
Sino reporter nito?
Sir, putol ang kay Ira.
Ah, ikaw na lang.
Wala daw pong signal si Ira.
Ikaw na lang. Save your group. Zyril. Any representative sa group ninyo? Slab gel electrophoresis. Okay? Zyril? Ikaw na lang, Zyril. Or Chelsea.
So the second one is the slab gel electrophoresis. Di ba may types of electrophoresis tayo? First one is the capillary electrophoresis, and yung ibang types ng electrophoresis is under sa capillary. The second type is the slab gel electrophoresis. So what is a slab gel electrophoresis? It is defined as the use in the analysis of polynucleotides in such applications such as sequencing, restriction mapping, PCR, and mutational analysis. Diba, gidiscuss namin kanina yung treatment and application of electrophoresis. Commonly, electrophoresis is for the detection of proteins and DNA. So what is the standard use in slab gel electrophoresis? This is the polyacrylamide and agarose. Ang principle sa lahat ng electrophoresis is same lang siya sa electrophoresis alone. Same lang ang mga types, ang lahat ng principles ng lahat ng types ng electrophoresis are the same. But naga-differ siya with the standard use or as we call the support medium. Doon lang siya nagaiba. So the second one is the immunoelectrophoresis. This is defined as or refers to precipitation in agar under an electric field. Again, ang standard use niya is agarose gel. Kung nakinig kayo sa discussion ni Zyril about the difference between the support medium, malaman nyo kung bakit agarose gel ang gamit. So the next one under the slab gel electrophoresis is what we call the isoelectric focusing, or as we call IEF. It is a modification of electrophoresis except that the separating molecules migrate through a pH gradient. So the standard use is the immobilized pH gradient consists of acrylamide gel. Actually, this is polyacrylamide gel, not acrylamide gel. And isoelectric focusing, when pH equals to pKa, there is no net charge on a protein. This point is called the isoelectric point. It's when a protein has no charge. In isoelectric focusing, the protein doesn't move.
Hello, okay na?
Yes, sir. Okay na po.
Okay, so mayroon akong addition ha. Mayroon akong addition. Sinabing isoelectric focusing. As paki-take note, in addition sa isoelectric focusing, ang supporting media na ginagamit natin dyan ay yung agarose gel polyacrylamide gel at saka cellulose acetate. Okay, paki-add. Okay, your supporting media na ginagamit sa isoelectric focusing ay yung mga agarose gel, polyacrylamide gel, and cellulose acetate. Okay? Okay, class. One of the advantage class of isoelectric focusing class is to detect your CSF oligoclonal banding, no? To observe for your multiple sclerosis. Check the CSF oligoclonal banding to observe multiple sclerosis. Okay, pakisulat dyan. Pakisulat ha. Okay, sige. No? Hello? Irene.
Two-dimensional electrophoresis. First dimension, proteins are resolved according to their isoelectric points. Standard use, immobilized pH gradients using polyacrylamide gel. The second dimension, proteins are separated according to their relative size, the molecular weight. Standard use, sodium thiosulfate polyacrylamide gel electrophoresis.
Okay na? Hello?
Yes, sir.
Okay na?
Wait lang. So, in conclusion, sa report namin sir, wait lang po.
Chelsea?
In conclusion, with our report sa electrophoresis, tandaan nyo that the principle of electrophoresis is the migration and separation of charged particles under the influence of an electric field. Tapos, kailangan nyo din tandaan ang components of electrophoresis, like the electric power, the support medium, the buffer, and the sample and detecting system. Because these components of electrophoresis plays a vital role sa mismong electrophoresis na procedure. And in every types of electrophoresis, they have the same principle but differs with support media. And sustaining din, naga-differ din siya. That's all.
Okay, thank you so much, all our reporters about electrophoresis. But before we end class, no, may I ask this question, okay? Ano ba ang ginagamit as to detect or to measure the absorbance of stain sa inyong electrophoresis? Okay? Di ba, mga stain man no, ginabutang sa gel. So pagkahuman anak class, ibutang na siya sa isa ka machine. Okay? Unsa man na siya nga machine, okay? Detector of the electrophoretic sample or detector of the electrophoretic stain. Okay, sige. Ano ba ang sagot na yan? Pakisulat lang sa ating comment section ang sagot. No? It measures absorbance of stain. Ating electrophoresis. So, di ba, sa inyong electrophoresis, kay naaman yung mga stain no, nagigibutang sa gel or ana. So, unsa to ang machine? Okay? Yun, sabi ni City. Shout out, sir. O, shout out, mega shout out to our vlogger, City Sakira. Okay, mega shout out sa iyo dyan, City. Yan, hi, sir. Okay, may nakasagot na class. May nakasagot na. The correct answer, class, is densitometer. Densitometer. Okay. Very good. The correct answer is your densitometer. Okay? It scans and quantifies.
Sir, iba, ano po na akong namumuid ako kayo?
Okay, it scan and quantify electrophoretic pattern. Okay? Sige. Densitometer. So please don't forget na additional nato. Yan. Okay, so I think wala nang mga question. May mga question pa ba? May mga question pa ba? Wala na. Okay, kung wala nang question, class, pakisulat, class. RMT ako 2020. Sige, pakisulat sa ating comment section. RMT ako 2020. Zyril, before we leave, Zyril, ikaw muna ang mag-lead ng closing prayer natin, ha? Sige, hintayin muna natin yung mga answer ng inyong classmates.
Sige, wait lang.
Okay, Zyril, I think wala nang question ang mga classmate nato. Okay, kindly lead us the closing prayer.
Okay. Classmates, let us pray in the name of the Father, the Son, the Holy Spirit. Glory be to the Father, and to the Son, and to the Holy Spirit, as it was in the beginning, is now, and shall be forever. Saint Marceline, pray for us.
Okay, thank you so much. Thank you so much, everyone. If you have any question, class, just leave a comment down below. Thank you so much, and enjoy your class. Enjoy mo sa inyong next class. You're welcome. You're welcome. Yan. You're welcome, Asian Nova. Kani Zara, unsa imong kwan Zara? Unsa imong ginabaligya? Chingkay, kamusta dara ang connection nato sa Tiboli? Okay lang ba ang connection? Chingkay, okay lang ba ang connection?